Hello guys, as I promised, I need to make a video of how to use the Vivado flow to, construct an IP that can be unders- understood um, by the PYNQ framework. So today I'm going to do a very simple thing, just an adder written in RTL. I'm going to write some data into it and read the results back. So the result will be adding the two input numbers. So what I'm going to do is I'm going to, make a, very simple. For instance, I have one adder there. Let me see what is going on there. Okay, it's not a big deal. So I'm going to, how do I, what should I call it? Maybe, um, I will do, I don't have a good name. AXIadder maybe. So I'm go to AXIadder and then I go to Vivado so I can make a Vivado project. So if you are familiar with this flow, you know that you have to prepare everything for you to package your IP. So let's get into that. Next, project name, let's call it AXIadder. Create project subdirectory, which is fine. RTL product, which is fine. I'm going to create a file. So file name, let's call it AXIadder. Okay, next. No constraint needed. No constraint needed. So I just need to go through this. I don't need to specify any specific board, but default part is vertex 7. Um, so which is fine, I think. But I'm wondering if this is going to affect my license. So I'm just going to choose the one, choose the pink one, choose the zinc device, zinc 7000. Well, when you package your IP, you are allowed to, well, actually, it's just to choose all. So when you package your IP, you are allowed to choose those things. Reside. Let me find the, you don't have to, well, if I go back and go next, well, you still have to, let me find the zinc device number. So let me see, ping C1, XC7Z, 020. So let's just choose zinc there. I know the number, since I know the number, XC7 7020, so it should be something around here. 400 CLG 400C dash 1. I think it's this one. It must be this one. CLG 400 dash 1. Yeah, I think it's this one. Anyway, I'm going to choose this as default because, well, let's not worry too much about the device number because later when you package your IP, you are allowed to choose the supported device. So even if you selected the wrong number there, you should be able to. well, actually, I should have selected the default selection, direction. So let's not worry about, putting those port numbers there, port names there. Has not changed. I should want to use these values. Yes, because we are going to write our own RTL anyway. So it's fine that Vivado is not doing everything for you. So you can make some changes there. Engineer, just put my name there. Axi adder. Let's just do input. I almost forgot how to write Verilog code. So I'm just going to write some random things there. Um, well, perhaps I'm going to make some mistakes there. Um, I hope I don't make too many mistakes that confuse the uh, users. So let me check a few things. I've been written RTL codes in, haven't been written it a lot since 2015. But let me try my best. I think it goes this something like this. So for the adder, let's just choose it to be parameterizable, so people will be actually able to, you know, change the length, width, let's call it. Input A, I want it to be width -1 to 0. Same. Oh, th -1 to 0. And output will be um, width to 0, C. Right? I don't need this one. So go to here. Why am I having something wrong there? I think it's here. Should be fine. What am I doing wrong? I think I'm okay there. Input. Okay, sorry. Comma. And then go to this one. I'm gonna have, well, I don't need it to be combinational logic, so I will just assign, well, um, A plus B. This should be fine. So 4 bits input, two two inputs. So you can produce C of 5 bits, right? So I think this is fine because it's a very simple piece of code. I don't need to run the simulation again. So I just need to create a package new IP, create a new AXI peripheral, name AXI adder. 1.0 is fine. Description, um, adder IP with AXILite interface. Okay. IP repo, which is IP location. This is fine. Next. So this is how it actually looks like because we're just using AXILite interface. So it's actually one interface is enough. So it's a slave interface at 32 bits. Number of registers that we can choose for. Um, but actually we're not using that many, right? So A, B, and C. But we can choose this to be 4. So I want to make sure that A, B, C can be as large as an integer. So click next. Edit IP. So you will be opening a different project to modify your IP. So remember that we are just using the AXILite interface. We're not putting a streaming interface there. So performance-wise, it's not going to be very good. But for demonstration purpose, you will it's pretty easy to make sure that you have the um, correct thing. So one thing, the vendor, I think I should choose. Let me see. I think usually vendor we usually choose Xilinx.com as the yeah. So usually I just choose library user name AXI 1.0 display name just maybe not v1. Just 1.0 vendor display name just leave it empty there. Company URL I don't need to add that. Compatibility here, this is important, so I need to add all the families. Make sure, well, actually I don't need to make sure all of them. I don't want to spend too much time synthesizing things like that I don't want to support. So just Zinc and Zinc plus pre-production to make sure. Okay, now you have those file groups. So I need to make sure that the files are actually working. So if I look at this, this is a original code added by the Vivado. So the top level has something interesting there. So you need to add user parameters and user ports as well. Um, what I'm going to do is I'm going to, because I haven't been working on RTL for a long time, so I'm going to probably try a few things to see if it actually works. If not, then I need to change the things and start over, basically try and error. Um, user parameters, so I can just add parameter width. Give me just a second to double check one thing. Um, yeah, parameter width equals default number. Let's choose it to be 10 or I don't know. Let me think. Maybe choose 4. And then since it asked me now to modify parameters after this line, so I won't change. So only one parameter I have added, which is the width. So you'll be able to see the slave register there because you chose 4 slave registers. So you will see 0 to 3. And those can be kept original. But what you have to do is I think there's a user ports that I need to add. So where is it? Let me see. Yeah, user ports here. You need to add those. So let me see. So I need um, output of A because with -1 to 0 A because you know this is interface between your IP and your actual between your PS side and your IP side. So the input and output ports are actually flipped. So this is not a mistake. So output has to be so what you put output here will be the input to your actual pipeline or actual logic, right? So um, here, so the input will be width to 0 C, right? And then if I go to the very end, let's choose slave register 0, 1, and 2, right? So I'm going to assign. Okay, so there's one thing. So you are only taking a few bits out of the slave register. So what I'm going to do is I need to add additional wire there. So let me see. Should be a place to add. There should be a place to add wires. Um, if there's not, I need to add by myself. Nope, there's no such thing. So I need to add by myself. So let me define a few things. Let's call it a wire, which is from um, this -1 to 0 a wire. Let's copy this. Oh, sorry, wrong, 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 wrong. A-wire has to be 32 bits, so it's actually this width that you have to take care of. Exit data width. So by default, this will be 32 minus 1. So let's do it 32 minus 2 because the maximum width you can get is um, 32. So just make sure C wire is 1 bit more than the A and B wire. Um, actually, we'll later constrain the width parameter never goes beyond 16, so you're sure that it will not mess up with the MSB, right? So assign A where equals slave register 0. There can be better way. B where equals slave register 1. C where equals slave reg 2. And then assign A equals uh, well, the first few bits. Let me see. Yeah, it should be. Looks like this. So okay, just looks fine now. So your S00 is taking the ABC, taking A and B from the slave register and putting C into slave register 2. So for the top level, I think there's something that I need to do. User parameters. You also have the parameter. Well, integer. Well, it's actually fine whether it's integer or not. I can just ignore this. Width equals 4 is fine. User to add ports here. Add ports. Is there ports? I don't think there are any ports. Right, there's no ports needed. So let's go to the final place where we include this AXI address. So you can see the same name here, which is the instantiating the module that we have just modified. So there's one parameter that we've added, so it should be called width. So we are passing the width in this module into the width parameter of the internal module. So everything here is fine. I think there's A, B, and C, right? So let me think about. Let me check if I'm doing something stupid there. Oh, okay. So I remember. So this is just a one module. So this module is instantiating the interface for your IP, but you actually have to instantiate you sorry. Let me talk about the top level module. So you have to actually instantiate your RTL code here. So your RTL code need to be added. So let's add one source. So your AXIIP has to be there. Let me see if I can find it somewhere. No. AXI Sorry, I was confused. But okay, this one. So if I add that IP, won't well, it will be shown as a different module because it's not related to your top level module, which is AXI address v10 there, because you haven't instantiated yet, right? So after add user logic there, I can just put something, let's call it AXI adder, and then followed by dot with um, instance. It's called instance. Almost forgot what I had to do. Dot A, dot B, dot C, right? So this should be fine now. So I need to connect those two together. Remember that we've added dot A there, dot B there, and dot C. Those have to be connected with your IP. So um, the upper one, this piece of code is related to the modules that we just edited for the slave registers, right? So the lower part is your logic, which is a combination logic where C equals A plus B, right? We need to kind of connect them together. So I need to instantiate some wires there. So it's not a port. So let's not confuse ourselves there. I think it's after the instantiation. Okay, let's put it there. So wire with -1 to 0 a where. We can also use a where there, but um, let's just use internal signal. So AI needs to be here, here. BI equals to BB. CI. Okay, now it looks fine. Seems like we have connected those two modules. So after you update this, you will see that it has the correct structure. So your AXI adder actually contains the module for your slave interface, and then also your instance defined for the behavior of AXI adder, right? So to verify this, the easiest way is to run synthesize to make sure it can actually work. Let's wait until it finishes. Uh, yeah, so this is a very simple design because we're not using any, well, it's synthesizing. Let's um, go through this together again. So the first, if you remember, the first thing you have to design such a Verilog code that, you know, well, it actually is pretty quick. So I don't have to run implementation. So you have to design your RTL code to make sure it has your correct logic. I didn't do simulation there, but in most cases you will have to, do simulation to verify that your code actually works, right? Then, when you package it to the IP based on the interfaces you chose, the Vivado will create some relevant code for you to modify, and then you just need to, if you remember, you need to add uh, the parameters that you want to have for this IP, or for this part, at least for this part, for this interface, and then put some ports to be able to talk to your original module. And then you have to keep in mind that you need to use those slave registers. So that's what we did for this slave XC module. And then on the top level, you will have to define some internal wire as well as some external parameters that you are passing into your design, like passing it two places. Um, and then you will have to connect those two internal modules together. Like in my case, I have this A underscore I, and I connect them. Um, so this should be fine. So it looks like synthesize is happy. You don't see any warning or error. So this is pretty good. So let's go to package IP there. We'll just merge changes. Thanks.com compatibility being reloaded. Okay. I don't know why it takes such a long time, but it should be fine. Merge changes. So I don't need to have a lot of those parameters because those are usually not user will not be able to configure them again. So just hide those parameters if I can see edit parameters. Visible, no, I don't want it to be visible because the XC also always has 32 bits. Why do I need to change that? I don't need it to be specify range. No. Okay. This one I want to hide it. Base address hide. I don't want it to be visible. So the only thing I want it to be visible is this width parameter. Visible, display width, um, number of bits per input. Um, Format, long is fine. Editable, specify range. Range of integers, minimum to be maybe 2, maximum is 16, or maybe let's do 15. 16 is fine. Now we're going to do that large number. Show range is fine. Default value is 4 is okay. So after I do this, you will see this width will be shown to the user and hidden parameters will be hidden from users. And you can verify the interface. Right now, there's only one slave AXI interface, which is good. Custom GUI, you see this is fine, looks correct, and nothing else. Review and package IP has been modified, yeah. AXI adder, archive name, archive location, AXI adder, IP repo, okay. I have to edit this, let me see. Package IP. Let's just keep this for a while, because although I already have this IP, excuse me, so I already have this IP, I want to try a few things before I will need to try this on the PYNQ framework. So this is a PYNQ board. So I already have it powered up. So I also have it mapped to my location. Let me see. Yeah. Go to this Jupyter Notebooks. Let me create debug. Sorry, byte typer. Debug. What am I going to do? Okay, sorry. One thing. I just created the IP, but I still need to kind of hook it up with the PS block I have. So what I'm going to do is, let me see if I can open a different one. I made so many mistakes, but this process is rewarding. So still going to try this. We're almost there. So what am I going to do? I'm going to do some hike thing, which is pretty dangerous, I would say. So let me copy the give me just a second. The PS7 block that I want to use. IP development 2. Let's not do IP development. It's actually an example of adder. So it has to be an overlay. So let's go to my CD workspace. dir PYNQ z1 XC adder, PYNQ z1 XC adder. Looks good. Going to open another Vivado project and trying to hook up the IP with my PIS module. Actually, I already have it somewhere. Okay, so I don't have to do this. So I personally have another GitHub repo. So let me close this. I don't actually need to do this. I need to copy the existing thing here. So PYNQ derivative overlay. I just built it So it's called bear. Oops. Oops. Right here. I'm going to, well, actually, let's put it into. This is a bear. It's kind of a bear overlay, which consists of a single PS with some additional reset modules. So I'm going to try to hook it up with, because the PS7 there in this bear overlay has the correct setting of PYNQ-Z1. So I'm going to reuse this one and start from there and add my AXILite IP into the block design. So right now, what am I doing is I'm trying to rebuild the block design. Actually, I don't have to run the implementation. So let's stop it there. Because this makefile allows you to make the block design without building the bitstream. So it's going to take less time. Okay, it's being finished. So it's not worry about the debug folder. Um, this is my place where the IP has been added. It's called AXILite. So I think it has been packaged somewhere here called IP repo. Yeah, this one. What I'm going to do is I'm going to go to the bear one. Where is it? Pink. It's work space. PYNQ-Z1 AXILite bear. So one thing is, um, let me try to do this thing. I need to make sure that it looks similar to the pink repository Z1. So I need to IP and make dir bors. I think it's called bors. Let me see. Yeah, bors. Oh, sorry. The bors has an IP and the overlay name. Yes, so this is a bear and IP are both there, which is not correct. So I need to PYNQ-Z1. Sorry, cd. Oops. Z1 XC adder dir bors move bear bors move IP into bors and go to bors. Actually, I don't have to do this. Sorry. I'll move. I can just trace this one as the overlay and then make dir ping-z1. Move bear into ping-z1, which is fine. I want to make it the same structure so I can have the same relative path for the IP repo. This is not necessary, but I always wanted to that to avoid any confusion. So in the IP there, you can actually copy the packaged IP. So if you remember, oops, I need to IP. I just need to unzip it. I don't need the zipped version. Yeah, yeah, this is fine. This looks great. I don't need the zip version. So go to my ping-z1 bear. I'm going to go to the ping-z1 bear. Go to the bear one. Going to open this one and try to add the IP. One thing that I need to make sure is that the IP repo will be added to the project. So after I modify the project, my plan is to rewrite the TICO file and also change the name so I can have a example design there. So if I open this, you see several modules, but what's important is you have to think set IP. Okay, so the correct way to set the IP, set the IP repo is go to your project settings. Here, project manager settings, go to your IP tab, repository, and add your repository. So after that, you will be able to search it. AXILite, it should be there. So double click, it will be added. So right now, there's no easy way, no direct way to connect your PS7 with this IP. So you will need to create XC interconnect IP as well. So it should be the second. Let's drag it there. So your PS7 also has to enable the GP port, so it can actually connect to that. So go double click PS7 module, go to XC GP master GP0, click OK. Then you will be seeing an additional port here, GP0. Oh, sorry. Let me go GP0. And then this one has to go to your slave of your S00 thing. And this one, I think it can only have one. Okay, let me try if I can. Okay, I can have just one master interface. So the master interface goes to this part, and then let's just use f clock 0, which I think is 100. Use this for all the clocks. The PS clock, F clock 1. Sorry. Let's see. S00. Let's all use the same clock. M008 clock. And then this clock. Let me check. I think this is also fine. 8 o'clock, but reside n has to go. Let me check the way if I'm doing anything wrong. So this is a little bit tricky. I think it's fine. The reset is coming from the PS reset signal. Yeah. So sorry for the distraction. So a reset n has to go to the same thing. Let me see. This is going. Yeah. So I was not sure about this A reset and this one. Yeah, I think it's the same. It both goes to the peripheral A reset and uh, yeah, this should be fine. Let's see. Looks okay to me. So let's verify, validate the design. Oh, seems like I have to map the address, otherwise it's um, giving me trouble. So unmapped slave. So this S is 0 to assign address. This should be fine now. Validate design again. Successful. Yeah. So I need to. So what I'm going to do is I'm going to write bdtickle, and I'm going to modify this tickle so that let's save it. Exit. Let's close this as well. I might be making some mistakes, but hopefully it's not too stupid. Because if I make too stupid problem, it makes user confused. Let's go to the bare one. I think it's this one. New.tickle. Copy this. Go to PYNQ I'm gonna make what do I call AXILite overlay? Probably no. Let's just call add overlay. And I'm going to copy some of this make file and tickle file there. I'm going to delete this because it's no longer called bear. DSA, we actually don't need it. Well, let's just change all of them. So new.tickle, so let's change the name. I think it's no longer bear, so it's called add overlay. It's a better name, but add. Okay, seems fine. Let's see where. So you see that you should be checking the IPs there, but it's not specifying the IP repository. So that's the reason why I wanted to make sure that it has the correct, the similar path as the PYNQ repository, because I can always copy something from PYNQ. Here, I think set change design name up there. So I'm setting the IP repo path to the IP repo, and then this should be fine now. Project one, no, it's not called project one. Add. Okay. Bear is no longer there. Project. It's no longer there. It looks fine now. So if I run make process, you should be able to build this. Add, add. It doesn't have to be this because I copied this file from the derivative overlay. I actually don't have to specify the device name. I just need to call this add.tickle. Bulk design bitstream, check timing, check batch. Let's first rename them. I hate the names. Check add, build add DSA. This is also add. Add.tickle we just modified, make file we just modified, and then check add, build bitstream, the overlay name and designs are all add. Yeah, this is fine. Build add DSA, so add. MXE GP0 is not exposed anymore, so we can remove that. GP1 is fine. Everything else is fine. Hopefully this will work. It's pretty simple, huh? Fingers crossed, this one should work fine to create a new overlay with my IP in it. So yeah, let's wait until it finishes. I'm sorry guys, I think I made a terrible mistake for the IP. So you can see the error message. Seems like there are multiple drivers driving a single night. I think I know what's going on there. It's not hard to find out. So if you remember, I think I made the, yeah, so I haven't closed this. So if you look at the S00XC interface, I'm actually assigning multiple things to a single input. So I have A var, B var, and C var. Well, if you look at the ports, output port A and B are outputs, but C is actually an input. C is an input coming from the AXI adder, right? So from the actual combinational logic. So I cannot do C here because C is an input, right? You cannot assign, you can assign output to some value, but you cannot assign input to some value. So that's the problem with slave register 2. So I need to delete this. I think well, let me see. Um, let me not delete that first. Let me figure out what to change. So if I look at this piece of code, I can identify a location where the slave register is being read, right? So that's this place. So I need to make sure that when I put the address there, I'm actually reading the correct thing, correct value. So I don't want to use slave register 2. Instead, I want to read the C where. Let me see slave register, whether slave register 2 is, I want to make sure that, okay, it's identified using reg, but it should be fine if I just put C where there. So if the address is 2, I'm just reading C where there. And C where can be assigned to C, right? So, well, it's actually more than that because C where is 32 bits by default, but C can be, some um, additional bits, right? So what I can do is I can combine this with the zeros, right? So I need to get, I don't remember the syntax for that, but I think if I do with minus one, sorry, with 20 equals C, this should also be fine. So C where, and well, I don't actually have to write this in multiple, but in multiples, um, in 2 lines. I can write it in 1 line, but I just don't want to check the syntax again. So I just take the shortcut. I'm just going to write some ugly code. Um, I know this could be optimized, but I don't want to spend too much of my time there. 2 equals 0. This should be fine now. Save. I'm surprised that the synthesizer doesn't figure this out, but hopefully this is fine. The C where is getting from the C input, the first with bits, basically with plus 1 bits, and then the remaining bits will be 0, right? So the C where is then fed into this register output. So I'm going to save this and then repackage it. I need to repackage. Go to this. IP has been modified. Yes, I know. Merge changes. Nothing else changed. So, but I need to rewrite this. Hopefully this will be okay to overwrite. Package IP. No, I don't want to close this in case I made other mistakes. So I need to copy it over. Sorry, where am I? IP. So I think I put it there. I think, yeah, this is the latest one. Copy this. Remove this. Unzip. Should be there. Remove the zip file. Should be fine. Now I make clean and do make. Let's wait until it finishes. Sorry, another mistake. I just stopped the make flow directly because I think I made another mistake by checking the code. So if I check here, the with, so this line should be with plus 1, I think. So I need to repackage this, save it. Basically, everything that you modified, you have to repackage. File groups, you have to merge changes. Review. Let's make sure that it's the with plus 1. Okay. Override, yes. Package IP. No, I don't want to, well, basically goes through the same process again. So is it this? Yeah, this is a new zip file. Copy to the folder where my IP can be located. Delete the old one. Extract files. So go to the Vivado project. I might have made several other mistakes, but hopefully this time will be fine. Sorry, as I go through this process, there were some troubles, some things that I have come across, but hopefully this one will finally succeed. Um, all right, let's wait until it finishes this building. Okay, now it seems like it has run into almost the very end where it's checking the timing. I think timing constraints are met. So it's just going to build the final DSA, which is irrelevant to our stuff. So what I'm going to do is I'm going to just get the the HWH file as well as the um, bitstream and I'm gonna copy those two files onto the PYNQ board. So PYNQ-Z1, I think it's called AXILite. Add, I think it's here, and DSA, where's the HWH? Those two files are ready. So go to debug. I'm going to copy it here, and I also put a Jupyter notebook there. So well, actually, you can see right the add overlay has been built correctly. I'm going to go to this place, restart the kernel, clear output, and we can just wait until the kernel has been restarted. So first I want to import this overlay and I want to check what has been exposed in this overlay. So if I check the IP dictionary, I can see AXIAdder 0. So well, since it's called that name, I need to make sure that my code actually use that. So I can write into this. I write a 1 into A, write a 2 into B. So I read C, I got 3, right? 1 plus 2 equals 3. There are some additional tests that I can do. I write I, from I equals 0 to 9. Write I into A, write another I into B, and then I check whether the output is 2i. So you can see 2, 4, 6, 8 seems like it's doing the correct thing. You can do some additional testing there. So this concludes this experiment. So, well, one thing to mention is if you're not familiar with this flow or if you're not so sure about the RTL code, there's always a way to do something else, right? So you can do the I think the most commonly used way is the HLS, Vivado HLS. But the bad thing about HLS is you have little control over the RTL code. So most of the user wants to have the performance of the hardware. So they will probably start with a simple HLS code, but eventually, if they really want to squeeze the clock cycle or use every piece of resource on the FPGA, so they really have to go to the RTL world. So they will have to eventually go to the Vivado RTL flow. So just as I did. So you will need to do this, the thing that I mentioned, add those interfaces, modify a few things, change the code, has, verify, even if you have some hardware bugs, you can debug with your, using your simulation for your IP. So there are many things that you want to do to stay inside in the Vivado world, not in HLS world. So I hope you enjoyed this video. This is a very simple example of using AXILite interface to communicate, between to do the communication between PLs and PL, and I'm doing the simple addition there, and you can do some other examples or your own piece of code. But as I said, the AXILite interface is not going to give you a very high performance because every time you read and write register values, um, is going to introduce some overhead for that read and write. So the best way to achieve high performance is try to use AXI stream interface. So you're kind of pushing a lot of data into the PL and let PL process it and dump it into the memory. So your PS can fetch data from the memory through DMA. So that's the best scenario. But this in this video, I was just doing a simple example of using AXILite, but you should be able to do that with other interfaces as well. A more complex example can be seen in the decision tree um, IP that I've posted. So I don't think I'm going to put this onto GitHub, this example, because it's too simple. I think everyone should be able to do it. The Python code is simple. You just essentially the overlay class and calls out the internal hierarchy inside the overlay by read and write method. That's pretty straightforward. And on the Verilog side, the RTL code is not that hard. It's just a simple design, a simple combinational logic without doing any clocks reset or some specific hard data processing. So hope you enjoy this video, and let's see you in the future. All right, goodbye.